Hello guys, today we'll continue our last topic of operators in Verilog. So in the previous tutorial we had covered the bitwise operators, and today we will cover arithmetic and shift operator. Um, Shift operators, as you can see, there are left shift and right shift, arithmetic right shift and left shift, and arithmetic operators such as multiply, divide, add, subtract, and modulus and power. So we will implement it on the coding platform, and let's see how we are getting the outputs. So for that I will be taking one example of arithmetic operators, that is 4 by 3 bit multiplier I am taking. So usually this is the terms for designing a 4 by 3 bit multiplier or any multiplier, as the n is the number of bit of the multiplier and multiplicand is 3, so number of AND gates would be n by 3 and number of adders would be n minus 1. So if you are designing a multiplier using the logic gates, then it can be done by as such also. But how you will define the multiplier using arithmetic operators and shift operation, and let's see and look into it. So before that I would like to show you that how you will perform that using a shift operation. So I will show you using slides. So suppose this is one of the input 1 and this is the input 2 1 and this is 2. So input 1 is a 4 bit and input 2 is a 3 bit, and we have to multiply it and see how we can do it using an arithmetic operator and shift operator. So we'll take a 0th bit and multiply. So what we'll get, we'll get the multiplication as it is. Then multiplication with the second bit of input 2 will leads to 0 here. So for that we will shift this second bit answer one bit towards left. So for that we will get 0 0 0 and 0, and final bit is 0 1 1. No, here you will shift by 2 step bits. So now you will get 0 0 0 1 1 1. Now what you will do, you will add this. So we'll get 0 1 1 0 carry 1 0 carry 1 0 carry 1. So this will be your desired final output. Sorry guys for the bad handwriting because it is a virtual pad. So let's switch to the coding part and implement the same thing in a coding format. So, here I have implemented one code for multiplier 4 into 3 bit. I will let you understand this, that I am taking first input as input 1 and second input as input 2. So input 1 is 4 bit, input 2 I have assigned as 3 bit, and output I will take extra bits, and I will need some intermediate wire, so I will take as such. Now first wire I will assign by multiplying the 0th bit of second input with the whole bit of first input. Now in W2 I am taking first bit of the input 2, multiplying by all the bits of input 1. Now we need to shift this W2 by 1 bit, so I am assigning that into W3. Now W4 is the last bit, that is the third bit of input 2, multiplied by all the bits of input 1, and shifting it by 2 towards the left, so I will get W5, and my output is addition of all the bitwise multiplication. So W1, W3, W5, that will be the final output. So your operands we are using like plus, multiply, and shifting. So let's run it and see the desired result we are getting or not. So I will save it and then I will run it. So the process of synthesis is almost going to be completed. Now after completing, we will simulate and see the waveforms and see whether it is matching with our calculated result or not. Simulating it. So the first input was 1110, and if you are trying to give more bits, it will not allow, because in the code you have assigned the input 1 to be 4 bits, so it will take only 4 bits. And second one we will take 101, apply, okay, and then we'll run it. So yes, this was the result we were getting, and one extra bit, that is taken as 0. So yes, we are getting a desired result. This is how you will perform a multiplier using our arithmetic and shift operators. And we had already covered a logical operator and bit operators in the previous tutorial. You can go through it, and remaining other basic tutorials are also covered. So you can go through the playlist and and exercise more on different types of example, and do comment in the comment section if you find any difficulty with the logic, or if you want to learn something different, or another exercises on Verilog platform. So till then, stay tuned guys, and please do like if you like the learning part, and stay safe, and let's meet in the another tutorial. Thank you so much.